This is Flyman Education, and today we're explaining the first subtopic in topic 1, stoichiometry of IB chemistry. So the first subtopic in this chapter is nature of matter and chemical changes. So then first off, the first subsection is phase change and state of matter. So for this topic, I usually like to do a triangle that each of the vertex of the triangle is one of the state, and the phase change would be different arrows going to different state with a specific direction. So here we would start with liquid, and the phase from changing from liquid to gas is called evaporation. And from gas to solid, we use the same arrow with the same direction, is deposition. And from solid to liquid, the process is called melting. So we can also go the other way around, and we will use a red arrow to represent this phase change. So then we go from gas to liquid. This process is called condensation. And going from liquid to solid is called freezing. And from solid to gas, it's called sublimation. So a few note for this this subsection is that when you later on when you write the equation for the chemical reaction, always try to indicate the phase of matter in the chemical equation, because the more complicated the reaction is, the more important that we need to make sure the phase or the state of matter is accurate to what was said in the prompt or in the question. And the second note is that do not confuse the aqueous state for the liquid phase. So the difference between these two is liquid means the state of matter in the form of fluid or liquid, but aqueous is a solution where the solvent is a liquid. Sometimes this make a big difference. For example, water in the form of liquid, you can write L. But for example, like a solution of sodium chloride or potassium chloride, the state of those solution is aqueous because it would be salt dissolving in water and not as a liquid form. Okay, so after this, we'll do a table to compare the three different states of matter. So this is to provide you with some vocabulary when they ask you to, for example, to describe the particles in the solid state, for example, then you would have the vocabulary to describe those. Here we are comparing between the three, so you will learn about all three states at the same time. Okay, so then we make a table with the three columns that said solid, liquid, gas, and then we would create this table with 4 rows, which is the 4 thing that we are going to compare these 3 states in. So for the first row, we would write the movement of particles. And in solid, the particles are usually close to each other, and they don't, because in solid state the particles don't move, but they do vibrate. So remember to that keyword, either vibrate, vibrational, to describe the movement of particles in the solid state. And the movement of particles in the liquid state is usually free movement. So for example, in water, we can see the water molecules can move wherever they want to. And in gas, it's also free movement, but the particles now are further apart and they move faster because they have more space between each of the molecules. And the second point, distance between particles. As we said, the distance between solid particles is very close by. Liquid is the same thing, but gas is far apart. Fixed volume, solid, yes. Liquid also, yes. But for gas, the volume can be changed and it's also compressible. And for fixed shape, the solid has fixed shape and is also rigid. For liquid and gas, the shape is not fixed. Moving on to the second section, classification of matter. So all matter can be divided into two type, which is mixture and substances. So mixture is meant to describe two different substances that is mixed together. So we have two different type of mixture, either homogeneous or heterogeneous. So homogeneous mixture, that means the components are in the same phase and the particles are equally distributed. For example, like in alloy, which is two different type of metals mixed together to create a mixture, or a solution, which is the ions mixed with the molecule in the liquid or the solvent to create a homogeneous mixture. And the second type, heterogeneous mixture, is when the components are in different phases and there are physical boundaries between components. So that means either liquid mixed with solid, or solid mixed with gas, as long as it's two different phases. That's a heterogeneous mixture. And for substances, we can also classify it into two, compounds and elements. So for compounds, those are meant to describe either ionic compound or molecular compound. Ionic compound is when a metal atom is chemically bonded with a non-metal atom. And molecular compound is just non-metal react with non-metal. And also elements, we can classify it into two, either metal or non-metal. Okay, and then next up, we have different types of formula. So we have three that we need to know in this chapter: molecular, structural, and empirical. So for this, I also want to do a table to compare the three, because people usually mix these up. But as long as you remember how the table looks like and remember what is the key difference between these three, you'll be good. So the first row that we'll be doing is we'll have an example, and then the second row will emphasize on what type of what is that formula trying to emphasize in that molecule. So first, for molecular formula, let's use ethene as an example. So that means for molecular, ethene would be C2H4, and this type of formula emphasizes the different number of atoms in a molecule. So we can see directly here that is 2 carbon atoms combined with 4 hydrogen atoms. And the structural formula is to show the bonding between atoms. So here we can see the double bond between 2 carbons and the single bond between carbon and hydrogen atoms. And the empirical is to show the simplest ratio of the atoms.